Great. So, welcome everyone. Today is, I think it's a bittersweet day. It's a bit bitter because it's the last FORGENIUS webinar. I mean, it has been like 5 years since we have been here all together working for EUFGIS and to upgrade this platform. But it's also sweet because we are now in the end and we have the EUFGIS live, and you will see more about this today. But before I give the floor to Michele to start like going around the new EUFGIS, I would like to give the floor to Ivan Scotti, the FORGENIUS coordinator, so that he can give some maybe last official words from the side of the project. So
Thank
Ivan?
you very much. Thank you very much, Anna Maria, and thanks for everybody for attending this meeting, this webinar. Yes, it's true. It's been a very long and exciting journey. I have really to sincerely say that I have taken my pleasure working with you folks and steering this complicated thing that is a Horizon 2020 consortium. But it was a great thing. I think we can all be proud of the achievements that we have reached. And as I very often say, it's rare. It doesn't happen very often that you figure out something that should happen by the end of a project, and 5 years later, you land exactly where you expected to be. And so it's for me a very pleasant surprise. And of course, I have to say that this has happened because everybody has invested a lot of work in this. And so I'm really, really pleased that today we are going to see the outcome of this project. And once again, I thank everybody for having contributed and everybody else for being here and listening to the presentation. Thanks a lot.
Thank you very much, Ivan. So without further ado, I think that it's time to dive deep inside the new EUFGIS, and I will give the floor to Michele so that he can walk you around the new EUFGIS platform. Michele?
Good morning, everyone, and thank you very much, Ivan. Thank you, Anna Maria, for this introduction. I will start now sharing my screen. I hope it's visible. Before I start this live demonstration, I will need to just provide a very brief overview on about some of the terminology that we use and some of the principles that are guiding our work. So first of all, allow me to very briefly explain what is EUFGIS. So first of all, it's an information system. It's much more than a database. In EUFGIS, we collect information about the genetic conservation unit that I will present in a few minutes, but also we add information linking existing sources, existing database, and providing a characterization that make it much more complex and more informative. EUFGIS provides georeference information on the status of conservation of forest native resource in Europe. And this is how it was designed and how it was developed initially starting from 2007. So EUFGIS provides detailed data on genetic conservation unit of forestry species throughout Europe. And is a documentation platform on the status of conservation. So it's not only the screenshot of what is done, but it allows us, thanks to the development, really to have a way to monitor the status. Monitor from the point of view of the countries that are trying to achieve the conservation target, but monitor for other actors, other stakeholders that are interested in forest native resources in Europe to have the full picture, both from the point of view of a country, but also from the point of view of individual species. EUFGIS was developed by the EUFORGEN program. EUFORGEN program is committed to its further conservation, maintenance, and further development. But EUFORGEN also use EUFGIS as an important tool for our work. For the well, as I will present later on, for the monitoring and for the implementation of the European Forest Genetic Resource Conservation Strategy, but also again to have a precise overview of the status of forest genetic resources in Europe. So I've been mentioning these genetic conservation units, and I think it's important just to make sure that we are all on the same picture, that very briefly I explain what is a genetic conservation unit. So a genetic conservation unit is a piece of land, normally covered by forest, that meets a number of minimum meet a number of minimum requirements. Those minimum requirements have been developed by the EUFORGEN community in order to make sure that we speak the same language throughout Europe. These minimum requirements, they indicate that indicate if the genetic conservation unit meets a designated status, meaning that it has to be established for the conservation of the genetic diversity of the species. It looks at the minimum size of the unit, minimum size in terms of number of reproducing trees. And we develop, depending on the purpose for establishing this conservation, we develop different thresholds. It must have a target species, so it cannot be just a general conservation for anything or for any genetic diversity, but the conservation of specific species need to be really spelled out. And this is important because we also want to have the possibility of managing the genetic conservation unit to ensure that the targeted species can reproduce and adapt. And this management very often is a source of well, it can be a source of conflict, it can be a source of different views, because very often we're looking at protected areas, but this is really crucial because then we can make sure that the genetic conservation unit is adapting. Managing doesn't mean harvesting timber, or doesn't only mean harvesting timber, but means that there is a local authority that is responsible to make sure that this unit is adapting to the climate conditions, is evolving, and sometimes this evolution is doing nothing, but sometimes is active intervention as well. And then we want to have a monitoring, because we want to make sure that the status of the conservation, the status of the specific population in the genetic conservation unit is continuously monitored. So these are the minimum requirements for a genetic conservation unit. And those minimum requirements have been passed to the EUFGIS data provider, which are the EUFGIS national focal point in the 37 countries that are providing data. And they look both on what is already existing in terms of conservation, if they meet the minimum requirements, and on the other side, they establish new genetic conservation unit, already have in mind what are the minimum requirements that they need to be met. So without the continuous work of this data provider, the EUFGIS national focal point, it will not be possible to have this important tool. So let's start having a look at what are the data that we currently have in EUFGIS. So as of today, there are a bit more than 3,500 genetic conservation units throughout the whole of Europe. And then these are for 116 tree species in 37 countries. There are more population than genetic conservation unit, because in some cases a genetic conservation unit can be established to conserve the genetic diversity for more than one tree species. As Ivan and Anna Maria mentioned, through the FORGENIUS project, there was an important upgrade of EUFGIS. But why this upgrade was needed? So we move from simply storaging of information to services. So the original information system was only storing basic administrative and stand level data without really providing any kind of genetic, phenotypic, and detailed environmental information. The new data and the analytic output could not be integrated into the new structure, meaning that projects like FORGENIUS that have been studying specifically genetic conservation unit, the genetic and the phenological aspect of a genetic conservation unit, there was no way to properly link them with the old information system. So this was a really important upgrade that was needed. So that's why we needed to do a full redesign of the information system, and then so that we could have a richer data set, and also to improve the accessibility of the information system and have something that could last in the long term. The FORGENIUS project, one of the main things they did was really characterizing, as I mentioned in my second point here, it was this characterization of the genetic conservation unit. So why this characterization is so important? So we did it to meet the user need. So the user on their side, and this was something that this kind of need was identified through a consultation at the beginning of the FORGENIUS project, well, actually even in preparation to the FORGENIUS project, but also during various phases of the project. So identify what are the user needs that they require more than just the data of what's where the genetic conservation unit is existing, but more indicators, and then something that can be summarized synthetically. The characterization will also enable the managers that are responsible for the specific genetic conservation unit, but also the policymakers to have a full picture of the status of conservation and what could be the needs, and breeders in order to have more insights on what actually is being conserved. It's also important to support and harmonize reporting so that they can turn complex scientific information into something that can support decision making at the local and European level. So how this characterization was done within the FORGENIUS project? So all the genetic conservation units that are currently in the information system, but any new genetic conservation unit that will be added in the future will be characterized with climate and remote sensing data. So all of them using existing databases and existing information systems, but also using remote sensing once a year within the it was done within the FORGENIUS project, but from now on, starting from 2026, it will be done by the EUFORGEN program. All the genetic conservation unit will be characterized harvesting new data from remote sensing databases. Within the FORGENIUS project, something like 10% of genetic conservation units have been characterized from the genetic point of view, and about 5% with phenotypic data. And we will dive into it very briefly. So this is the URL, eufgis.org, to access the information system. And I think I should be able now to switch from my PowerPoint to, I hope it's visible now, and this is the live part of my demonstration, where you can see what we currently have in EUFGIS. So this is the home page, and you can have a very broad, a very quick overview about where are the genetic conservation units throughout Europe. You can switch and see what are the 3 species. Most of the conservation effort originally was done on very few species, but we could monitor throughout the years since we have data that we have been reporting to the Forest Euro process since more than 20 years, and we could really observe a shift. At the beginning, it was only very, very few species that were accounting for most of the conservation effort. Now, even if we still see a quite unbalanced preference for conserving species that are economically very important, the number of 3 species it keeps increasing. And then we have the countries that are providing data. And then it depends very much on something is a basic ecological status. Some countries have very, very few species, but some countries have been already starting this process since very long. But in nearly all European countries, there is a continuous trend in increasing the number of species that are conserved, but also the number of diversity that is conserved within those species. I will just dive very briefly now into just one example. If we go under data and GCU and we pick, so you see the first interface that is presented is the list of countries and all the genetic conservation unit within the country. But we also see on the right side the species and the number of genetic conservation unit per species. I'm choosing a random tree species, Habeas alba, which is one of my favorite for this kind of example, and the result that we get is the list of genetic conservation unit for Habeas alba. Now I will just try to get a genetic conservation unit that is more complete, because then it depends very much on both what data have been provided by the national focal points and also what kind of work was done in the framework of the FORGENIUS project. So what we will get now is the interface. Here it is. So this is the genetic conservation unit in Spain conserving Habeas alba. And the first thing you notice is that here on the left side, you have two portions, basically a series of 4 tabs, one on genetic conservation unit in gray, and close to it, something that describes the site. So the genetic conservation unit are the data that have been provided by the national focal points, and you can see here a list of data provided by these focal points. And then there is another tab that describes the site. Here we are already diving into the characterization that thanks to the upgrades done in the framework of the FORGENIUS project is possible to access within this information system. Sites, you have climate data, and then within this climate data, you see that we use data from 2 information systems, 2 databases, CHELSA and WorldClim. And what you see here visualized is the CHELSA data. We describe what is about this CHELSA so that you can have a reference. But then what is more important is that here you can visualize the data that we have been harvesting from this information system. And is part of the past data, past climatic recorded data, and what we can consider the current situation that includes part of the existing data and the first interpolation, and then the interpolation that goes to 2070 up to the end of the century. So these data are important for the local authority responsible for the management of the genetic conservation unit to know if there are some changes that are forecasted. And then you can see here another set of bioclimatic data that could be relevant, for example, the aridity index, and then to see what is the real status of this genetic conservation unit from the point of view of the climate. Something very important is the second tab that we call surface data, where this is here we are already showing data that have been harvested through remote sensing. What you will see here is that for all the years that are in this database, in this case we have the soil moisture index. Clicking on this tab, you can have an overview of what it means and where it comes from. And this gives a snapshot of what was the situation in 2022 as it is now. And even more interesting is looking what is the anomaly. What was the anomaly in 2022 compared to all the other data. So that is very informative for the local authorities to see what kind of challenges the genetic conservation unit have been specifically facing in this moment. We can look also about some environmental information. I forgot to mention before that the shapefile, so the polygon of the genetic conservation unit, is the data that the EUFGIS national focal point has been entering into the system. And this is important because we use this one to harvest the information for remote sensing. And in this case, you see what are you have the NDVI, and then here you can access to all the historical data. And of course, this comes from more sensing. It can happen that in some months, due to clouds, it was not possible to get this information, but for sure, then it can visualize it for other years. And again, also see is it possible also to get and download this data from the point of view of the local authority. So this is about the sites alone. Then if we look at the population, so it means what species is growing there and how is managed. And then you can see here the set of information that is provided by the local authority. In this case, you see that the number of estimated producing trees is more than 5,000, and there is managed. The justification for conserving it was to maintain genetic diversity in large tree populations. And then based on this information is what we allow to also to monitor the overall status of the conservation. Species that are still forming, we expect to have a much higher number of reproducing trees, while for scattered species, normally this number is reduced. In any case, what is important to notice is that we can also have a look at the specific indicators that we could derive from analysis in the field. In this case, as I mentioned, I was speaking a genetic conservation unit that we knew that it was sampled, and then you get an overview. In this case, for example, well, the originality of the GCU. Here you have the value that is derived and the sample size, and this can provide an overall information. This makes more sense when we look at the full picture of the genetic conservation unit that we will have a look shortly after this part of my presentation. Now I'll go back to my PowerPoint. So so far I presented what is the information system, the information that is provided, but then when I was into this EUFGIS, I also mentioned that we use this as a documentation platform for the status of forest genetic resources in Europe, and how EUFORGEN program is using it as a central tool. In order to better explain this, I need to speak just very, very briefly about the forest genetic resource strategy for Europe and the pan-European strategy that the EUFORGEN program conceptualized nearly 15 years ago. So very, very briefly, very synthetically, the purpose, the ultimate goal of this conservation strategy is done at the level of species distribution range through a network of genetic conservation units. So I already indicated what are the genetic conservation units, but let's see what is a network and how we make an assessment of the status of conservation. So this is an example of Pinus sylvestris, and you can see here all the genetic conservation units that currently we have into our information system. So if we overlap the species distribution range, you can see that part of the distribution range is covered and part is in some part of the range there are no genetic conservation unit. So in developing our strategy, we wanted to have something that could also work in total absence of genetic knowledge. For some tree species, like it's happening thanks to the FORGENIUS project, we really gain a lot of information about the status of the species genetic diversity, but in many cases we know very, very little about the genetic diversity of the species. So we develop an approach that allows us to have information about the status of conservation even without knowing anything about its genetic diversity. So in order to do so, we need to make an assumption. So we use a climatic environmental classification of Europe to characterize the species distribution range. So the assumption that we make is that if the species is adapted to different environmental conditions, it means that it has developed some adaptive capacity to survive in this kind of environment. So it means that the minimum level of conservation effort that the country should be doing is making sure that the species is conserved in the environmental zone where it's occurring in its country. So if we look here at Finland, which is quite visible, and you will see that Finland has two colors. So the minimum effort that Finland should be doing is conserving Pinus sylvestris in both the environmental zone that occur in the country. And for this, we can develop some targets. And here now, when we overlap the network of genetic conservation unit, you can clearly see that some genetic conservation, in some countries, the both environmental zone are covered. In some countries, there is still a lot of work that's in to be done. I've chosen Pinus sylvestris, which is one of the most widely conserved tree species in Europe. As you can imagine, their species, even if they have a very broad distribution range, are conserved in very, very few genetic conservation units in very few countries. But so here is what you see, the network. But then what is missing now is saying, okay, but how we can monitor the progress? So to monitor the progress of conservation and to see what is the status, well, the EUFORGEN program developed an indicator which was then presented to the Forest Euro process and now is used to report data on the status of forest genetic resource conservation in Europe. So this approach basically presents a set of 4 sub-indicators that individually carry different pieces of information and can be sensitized graphically. Here I very briefly present you what are the 4 sub-indicators. So a first one is the dynamic conservation in situ and ex situ on native tree species, and we can do it also a dynamic conservation of not native tree species. Then we also monitor the static ex situ conservation, and the EUFORGEN program was very active during the past phase in developing new indicators and stay tuned because there will be new webinars and presentations related to that. And the last sub-indicators is about the potential for production of forest productive material. What I will focus now is only about this dynamic conservation in situ and ex situ on native tree species population. So this is a sub-indicator, but this sub-indicators is divided in 4 verifiers. So the first verifier is the conservation effort. So it's nothing more than the number of native population, so of genetic conservation unit established for these species within for this species. So the second verifier is the country involvement index that goes, that is nothing more than the number of countries where the species is conserved divided by the number of countries where the species is occurring. And as you can see here, we derive a number that goes between 0 and 1, when 0 nothing is done and 1 is fully achieved. The third verifier is ecotype diversity index. Again, here we have something that goes between 0 and 1, and we have the total number of ecotypes where the species is conserved, divided the number of ecotypes within the species ranges, only looking at the countries that they're doing this conservation. So this means that, okay, we look at the previous verifiers, we look where what are the countries that are conserving. So within those countries that are conserving, we look, okay, this country is conserving, but in how many ecotype you are conserving that. And the fourth one is the insurance index. Okay, having a genetic conservation unit is specific and environmental zone, it is important, but if you have a backup, if there are more than 2 genetic conservation units, it means that the conservation effort of the country is more stable and sound. So in a numerical point of view, this is what it looks like, the picture of Pinus sylvestris throughout Europe. But what we said is that this can be visualized graphically. And here we see the number. So this is the dynamic conservation effort. So this is the total number of genetic conservation unit for Pinus sylvestris throughout Europe. And we can see how these have been increased throughout the year. Simply, this show what is the effort at European level for the conservation of Pinus sylvestris. But then here comes the most interesting part. So we say that this indicator can be visualized graphically. I mentioned before that we have a country involvement index, and that is nothing more than the total country that are conserving the species divided by the number where the species is occurring. And then here is very nice to see how since 1990 up to now, there's been a continuous trend of the countries that have started to conserve Pinus sylvestris within the country. What we see here on the bottom right is the ecozone diversity, which is the as I was saying before, in how many ecozone species is being conserved. Here we can see that most of the countries are somehow stable. So when they initiate, they start already conserving it more or less the same environmental number of environmental zone, and there is not a big trend in increases. And the insurance, you can see at the beginning there was very little insurance, while now this is also growing. So this kind of visualization is really important because it allows in a very easy and quick way to see what is the status of the conservation of the species within the country. Now, if we go back to the information, sorry, the live platform, and then I pick species. Now let's go back. Well, we have seen now Pinus sylvestris. Now we switch into Abies alba, and this is what I was showing you before. So this data are harvested directly from the EUFGIS information system that the national focal point are maintaining. So it means that in any moment when an EUFGIS focal point adds new data, these data are immediately visible into this platform. And then is not only the numbers, but is also this graphical visualization that allows to us to have a very clear picture of what is the status conservation. And this was done by species, but we can also decide that we want to do it by country. Let's see what is the situation in France, for example, and then we can see how the number of species diversity has been conserved in France and how much there is a continuous trend in increase and within the country. I would like to underline that this tool that we developed is not a tool to compare one country to the other, but simply to allow each single country to see the progress. As I was saying, it goes between 0 and 1. So even if a country has only 3 species, they can see the progress. But a country that has 100 or 3 species, it will still be possible for the country to see the changes. If we look now to another country like Spain, we can see again that the country really started the conservation effort more recently. Sorry, maybe Spain is not the best option. Let's go back to France. And what we can do through our information system now, we can decide that we select which are the year that we want to see, so we can visualize only some years. And this is all done querying the information system directly. So this is about the status of the conservation. But then, as you see here in the navigation menu on the top part, so I've shown you the status conservation for species and for countries. Now I would like to show very briefly the link information systems. In this case, I will look only to the FOREMATIS information system. FOREMATIS is maintained by the European Commission, DG Sante, and is where all EU member countries are expected to report information about the availability of reproductive material. This is now done and reported for all EU member countries, but now FOREMATIS be made available for all countries at least in Europe, so that they can upload this information. So if we pick again habeas alba, what we get through this query, and it is done with the live linking, we get information. You see here the distribution range of habeas alba. And then you see all in yellow, all the EUFGIS genetic conservation unit, and in blue, all the sites where there are seed source available in FOREMATIS. We can query the database also indicating a radius, because by default, the system will show all the genetic conservation unit, but we can filter and we can decide that we want to see only the site in the radius of 5 kilometers where there is a genetic conservation unit available. And when you click, you will see that, like I'm doing here, you can see that there are two sites in FOREMATIS where material is available, and then by clicking, then you can access directly both database, EUFGIS and FOREMATIS. So this is for, as I was saying before, this is for the information system that are linked. Before I conclude, I would like to underline that there are also some materials that will guide both the navigators and the scientists that are willing to better understand what was done in terms of the characterization, but also to further characterize genetic conservation unit. So here it will, from here, this interface is possible to download the FORGENIUS genetic conservation unit sampling protocols, and then this as I said, is to understand better what is available in the information system, but also to do further characterization. And we also have the manual for the information for our for this portal, and for this we are very grateful to the project partners that have been preparing this manual that make it much easier to understand and to navigate. There are also video tutorials that will make it possible for any browser to look at it and grasp in case the manual itself is not sufficiently intuitive. So the last thing I want to show you about this information system, but then there will be possibility for you to ask questions and to dive into other parts, is something that, especially from the genetic point of view, we found it extremely relevant and informative. If we look under data and then indicators, what we end up is an interface where we have all the possible indicators that have been developed by the system, where they can be accessed in very quickly. So I've clicked now on the genetic part, and what you see here is the list of the various indicators where that can be visualized graphically. Each of them will have a tab that provide information on how they describe what is what this indicator is visualizing, but also is possible to view what kind of data we have into our information system. It makes sense to look them by species, so you can access by species, and then you know already how many genetic conservation units have been sampled. So this is the case of the genetic conservation unit originality. So this is about the FCT value of the population that has been sampled. Of course, every time that new genetic conservation unit are added to the system, all the visualization part will be computed again. But this gives an easy glimpse on what is the status within the species distribution range, which actually can be added in the visualization. So this is one of the possible indicators that can be visualized. But then coming back to this interface, there is another indicator, and as I mentioned, all those data are visualized immediately based on what we have in the information system. So if we want to visualize the administrator index, then again we click, and then we see all the raw data, but then we can have a visualization by species. And what you see here is the administrator index for Aedes albα, and this is done simply visualizing the data that FORGENIUS project have been collecting in the fields, and the data have been uploaded into our information system. So this is done live, and then this is the idea is that while we make progress within Europe on the genetic characterization the characterization of genetic conservation unit, this data could keep enriching our knowledge about the status of conservation. I'm moving towards the end of my presentation. And then I think it's very, very important to underline the fact that EUFGIS, once the FORGENIUS project ends, will be maintained and further developed by the EUFORGEN program, which will, as you possibly know, is an implementation mechanism of the Forest Euro process. And then within the seventh phase of the program is clearly indicated that the community is committed to maintaining and further developing the information system. I would like to take this opportunity to thank, well, Ivan Scotti that led the FORGENIUS project, even from INRAE, that made possible to have this important upgrade of the information system, which really enable the forest native resource community in Europe to move to a completely new standards and to new capacity of knowing what is conserved and the possibility of strengthening the conservation level of forest resources in Europe. The technical realization of this information system was done by the Youth Vision partner, Valentina and Simone, and the database developed by Milko from EFI. I will not terminate this presentation without presenting my deepest thank to two work package leaders, Mari Rusanen and Marianna Westengren from Luken and from GIS, Luken in Finland and GIS in Slovenia, that made it possible to coordinate all the work that we have been doing, and it's thanks to the devoted and continuous work that now we have a very useful and strong information system to support forest native resource in Europe. And with this, I give the floor back to you, Anna Maria, and we can open the discussion online. Thank you very much.
Thank you very much, Michele. I think you gave us a full overview of the EUFGIS, and of course, there are many more details hidden in the information system. So now I will open the floor to all of you. In case you have questions, please raise your hand, your virtual hands, or type your questions in the chat so that we can start discussing. Either it was too much information in a very, very short time, or it was all very, very clear. I don't see any hands. Who wants to break the ice? Or maybe people are already inside EUFGIS trying to play around with the new system. Is anything else, Michele, that you wanted to cover and you didn't have time?
Well, maybe what we could do, we could dive into some other species example, but I think the purpose of this webinar was simply to introduce the system to a broader community. And I imagine, like you said, Anna Maria, now is the time to play with the information system and to see how data look like and what it can be done, how you can look and download the data. There will be disclaimers in case you decide to use the data, how to cite them, and this is something that will be really important. Ivan.
But because nobody asks questions, and of course I will not ask questions to you, but I'm going to ask a question to the audience, just to change the way we work. Of course, that being the coordinator of this project, that, as you clearly explained, Michele, not only created the structure, but also filled a part of it. I clearly see that there is a lot of room for continuing filling the information system with the missing information from all those GCUs we haven't characterized. So I'd like to ask the audience whether you, as from the standpoint of your national, let's say, research community and conservation community, how likely do you think it is that you will put efforts in characterizing the GCUs in your countries? I don't know if anybody has an answer to this, but I'd like to see whether people are ready to pick up from when we are going to stop.
Thank you. I see one hand from Anne. I don't know if it was from before or if you want to.
Yes, I want to answer also. Thank you for the presentation, Michele, and thank you, Anna Maria. My question was, in fact, related to the question of Ivan. So we indeed plan to go for more GCUs in Belgium and in Flanders, and to take more efforts to characterize them. But my question was, if we want, for example, to characterize them genetically, is there a monitoring protocol, or is there a kind of, because I didn't saw it in the protocols, with which marker system should we use? I suppose that we have to use the same SNP or panel that was already used for the species in the project, or can you help us with that, so how we could proceed to collect data that can be useful for the EUFGIS database, please?
Ivan, please.
Yeah. Well, first, the technical thing. It seems that some people have trouble writing in the chat. I don't know how. It's particularly Francois who is telling me that he's unable to do it. So maybe this is one reason why people are not very active. But anyway, the answer is yes, there is a protocol. What we did within the project was to say, use the most advanced marker system you have for a given species. We also said, as long as we use sequence-based data, DNA sequence-based data, this will always be, we will always be able to match, compare with anything that's been done before or after, because it's sequence. Of course, if one uses microsatellites and another one sequences, and so on and so forth, we will not be able to match and compare. But as long as it is sequence, it's going to be fine. And then, yes, of course, what we did now was to use the current state of art, and very much likely tomorrow things will be different, but I don't think that anybody will go beyond sequencing DNA. So I think that's DNA sequence is the reference. And to give you an extra piece of information, we try to approximately estimate the cost of characterizing the GCU with the current standards we have set. And if apart from the costs incurred by the institutions who go and collect the samples, so starting from the point where the samples have been collected, and then you have to do the characterization, we estimated it would cost, give or take, around 10,000 euros per species in a GCU. Which could be considered a lot or not a lot, depending on point of view.
Yes. Thank you. Thank you.
You're welcome.
Thank you, Ivan. And yes, you can find also information on how to sampling for the genomic parts in the GCU characterization protocols. And I would like to also say that soon we are working on a second version of the GCU characterization protocols, so it will be more enriched. There are already many information, but it will be also updated very soon. I have a hand from Konstantin, and then I also have one question in the chat. So Konstantin, we cannot hear you.
You're muted.
Kostya, we cannot hear you.
Your microphone, yeah. Your microphone is not working.
And I seen you again anyway.
Okay, so if you can type your question in the chat, or yeah, otherwise you can come back again if you can fix the microphone. In the meantime, we have a question in the chat. How is possible to download list of GCUs with coordinates? So CSV files to download gives just the list of the units. Michele?
Yes, this is for me, and this is something, this is very much related to the way we have an agreement with the countries that are providing the data. So some countries will allow access to the precise geographical information, but for some other countries, for privacy reasons, then this is not possible. So this is something that when it will be fully available, then it will be possible to download data only from the countries where is possible, where the geographical coordinates can be disclosed. It will still be possible to have and to see the full overview. This is also one of the reasons when looking at the information system that when you visualize some of the genetic conservation unit can appear to end up in the neighborhood country, because we still want to make sure that it's possible to see that there is conservation effort happening in one country, but then the dot is randomly plotted in something like 50 kilometers radius around the genetic conservation unit. So it will be possible, it's not fully operational now, but still when it will be possible to download only the genetic conservation unit for the countries that allow full access. Thank you. I think we are still waiting for the question from Kostya to be entered in the chat. Then we can see if there are any other questions.
Okay, we have the question from Kostya. So it's like, in what format are genetic data entered or stored, allele frequencies, individual genotypes? Ivan, do you want to?
Yeah, Yeah, the idea is that we submit VCFs, and then a pipeline treats them and outputs the indicators. And the answer to the second question, I think it's more for you folks. Are they accessible, downloadable?
I would say that they will be through the data papers.
Yeah. Yeah, because what we upload in the information system is indicators, so statistics based on the data, not the data themselves.
Not the VCF. Yes, the VCF files are not stored in EUFGIS.
But maybe you have to say a word about how this uploading works, because maybe people are not aware of the way the data are funneled through EUFGIS, national focal points, and so on and so forth.
This comes back to me. So we, within the framework of the FORGENIUS project, we develop also two interfaces. One for the EUFGIS national focal points, when in a very easy way they can access and upload information. They could even manually draw the border of GD conservation unit in case they don't have a shapefile immediately available, but then all the data can be entered manually one by one, or uploading an Excel or comma separated file directly. This is for what regard the first interface for uploading the data, which is the one for the EUFGIS national focal point. We develop also another interface, and it is an interface for the characterization data, meaning in our case it was the the FORGENIUS project partners, but in the future it can be any project that is developing that is characterizing the genetic conservation unit following the minimum requirement and the protocol that we developed. So basically using the same approach, then there is an interface that allow the scientists to upload the data. So basically, the first thing they will get, well, I'm not ready to give now a demonstration, but this is something it can be organized and make available later on. There will be an interface where basically the scientist that is interested in uploading data, that it can download a template, and then the template will be filled with the required information, including how to cite the data set. And then once data set is uploaded, it will be immediately available in the platform. I would like to underline the fact that in order to have a new project uploading the data into the system, a request needs to be submitted to the EUFORGEN program, where through the steering committee it will be evaluated and then decided if it can upload the data or not. Thank you.
Thank you. A hand from Francois.
Yes, it's not a question. Actually, it was a comment I wanted to put in the chat, but sorry, my chat doesn't work, so I use the mic. So I would insist on what you mentioned, Michele, as this is really services that are provided and not only information. And just to say that, for example, at national level, it can be used not only for monitoring, but for everyday technical activity. And for example, in France, we plan to use the benefit of these really dynamically updated climatic and remote sensing data to, for example, for the planification of field visits or things like that. So it's really a tool, I think, that a service that can be used not only for let's say regular monitoring or reporting, but also for almost everyday support to the national activities. That was just a comment.
Thank you, Francois. Then Anne?
Yes, I have one more question. You know that in many countries, a lot of things are going on with assistant gene flow and assisted migration of species and of provenances. I was wondering if there is a kind of for protecting the conservation units and especially the native populations, is there a kind of restriction that no other plant material from other provenances might be planted in the neighborhood, or is just maybe promoted to have some gene flow with other provenances? So because we have this discussion here in Belgium that conservation units should be protected with a buffer zone to protect them from foreign provenances and gene flow for foreign provenances. What is your opinion about that?
I can start replying, but then there are also many other representative of the EUFORGEN community that can intervene and complement what I will say. This is very much a national responsibility, and things are done differently in different countries. I see very well your point, and I agree that having indication about how to protect the individual genetic conservation unit, it can be crucial for the unicity of the species, but then it depends very much on the individual reality. In some cases, the local condition will no longer be suitable for the conservation of the given species, so then the attention need to move more from the site to the population itself, and then seeing if the conditions are considered no longer be suitable for that specific population, if the population can be, well, really in a sort of a system migration, moved somewhere else if the site is no longer possible. And this goes and open to the all the ex situ strategy that is important that within Europe we keep evolving and we keep implementing and developing as a complementation part of the in situ approach. I don't know if someone else from the project or from EUFORGEN want to react to this question. If not, then we can see if there are other questions. Anne, was this meeting your interest and question, or?
No, thank you. Yes, that was exactly what I expected from the answer. Yes, thank you. That's clear.
Thank you very much.
Okay, there was also another question if we will have particular personal data curators for individual species, but I think Ivan's reply in the chat covers more or less what is going to happen, and also what Michele said earlier about the fact that to add new data, this will pass through the steering committee. So it will be first an approval of having new data, and then it will be the responsibility of the national focal points, and then with the support of the Secretariat to validate the data. And then another question, will the date of the last update for each GCU be displayed?
So if the question is about the environmental and climatic data, so we use existing databases that are continuously updated. Normally what we do at the beginning of each calendar year, once the previous year data are fully available from basically from satellite, from remote sensing, then we run the characterization for the full data set for all the genetic conservation units that we have. As you can imagine, the data are massive and is a process that requires a couple of weeks. So we aim to do it only once a year, putting together all the data of the previous year. But then this depends very much on what are the sensors on the satellite, which satellite are available and provide access to the data, and this is something that is continuously evolving. Some data, as you could see, are no longer available after 2022, but new data are being, new sensors are being positioned into the various satellites. So it's a continuous process of developing and querying the existing sources of potential remote sensing in order to better characterize the genetic conservation unit. So if I get the question right, is the characterization that is done once a year, and then depending on the availability of data from remote sensing. Thank you.
Thank you. I don't see any other hands or questions. Is there anything else that should be clarified? Okay, if there are no other questions, I think we can... no, we have another question, please. Tore. Tore.
Tore, nice seeing you. You're muted. Wait, you're muted, Tore. Tore, you're muted.
Okay.
Now we can hear you. Thank you very much.
Yes.
Nice seeing you.
Okay. I would just like to congratulate you with the work that has been done with this activity. Being involved with EUFORGEN since the beginning of the 1990s, I see a very good development in all activities, and in particular, the presentation that has been given today. It's been very good and very informative. Thank you very much. And yes, thank you.
Thank you very much. This means a lot to us.
Yeah.
Okay, thank you. So if there is no more questions or reactions, then let me check the chat once again. Okay, so I think this should be the end of our webinar. I would like to thank all of you for being here, and don't hesitate to contact us if you need more information or if you would like to have access to any information and you have troubles. So we are here for you. Please get in contact, and then we would like to wish you a very nice winter break, and we will be with you through the EUFORGEN Secretariat for all the EUFGIS news that we will be having. Thank you very much and have a great day.
Thank you. Bye. Thanks a lot.
Thank you. Bye-bye.